Internet, welcome back. Today, this is day 2 of proving lines parallel, this time working with 2-column proofs. Now, allow me to explain how you should approach each 2-column proof. You should, number 1, never look at the 2-column proof itself. In other words, the boxes, until you finish planning. Number 2, read the problem or statement. You want to familiarize yourself with what's given and what you're trying to prove. Remember, what you are given is what you can assume true. Here, I encourage you to use this opportunity to write anything on your paper that may be useful. Number 3, mark your picture or diagram from the given by drawing relevant symbols such as tick marks for congruent segments, arcs for congruent angles, and or arrows to indicate which lines are parallel. Number 4, look at your picture. It is part of your given. Mark anything relevant that is necessary for the proof. You may need to refer back to your pink sheet for certain properties and or theorems. Know that anything from the pink sheets has been proven, meaning they are true or accepted statements and can be used in your proof unless stated otherwise. So use this opportunity to mark or note vertical angles, corresponding angles, etc. only if needed for the proof. Number 5, anything you mark down should be noted somewhere on your paper. This will ease you into the last part, which is number 6, to fill out the 2-column proof. Lesson 4, 3 notes, proving lines parallel, day 2. Number 1, it says given L is parallel to M, prove that angle 2 is congruent to angle 7. Note, this is the proof for the alternate exterior angles theorem. The note here means we cannot use this theorem in our proof because this is exactly what we're trying to prove. In other words, the alternate exterior angles theorem cannot be used for one of our reasons. Now, without looking at the 2-column proof, we're going to read the given. It says L is parallel to M. Whenever you're given something, you can assume that the given is true. So I'm going to write assume true. That means we can assume that line L is parallel to line M. And I'm going to draw an arrow here and an arrow there to tell the reader that those two lines are parallel. So we have parallel lines cut by a transversal, and what do we have? We have angles. Now remember, we're trying to prove that angle 2 is congruent to angle 7. Here's angle 2, here's angle 7. These two angles are alternate exterior angles. But remember, we cannot use that theorem for one of our reasons, so we're going to have to think outside of the box here. Again, you're going to need your pink sheets. Other than the alternate exterior angles theorem, anything on your pink sheets can be used as a reason. Now, if I look closely, I see angle 2 and angle 6. These two angles are corresponding to each other. So therefore, they are congruent. I'm going to mark my picture. I'm going to draw one arc here and one arc there. So I'm going to make a note. Angle 2 is congruent to angle 6 by corresponding angles. What else do I notice? Well, I see that angle 6 and angle 7 are congruent. And why are they congruent? Well, we have two lines that intersect each other, and the angles across from each other are congruent. They are vertical angles. So angle 6 is congruent to angle 7 by vertical angles. And a real quick note here, the reason why I'm drawing one single arc there is because it's congruent to angle 6, and angle 6 is congruent to angle 2. They should all have the same measurement. Now look what I've written down. I have angle 2 is congruent to angle 6, and angle 6 is congruent to angle 7. What does that imply? Well, let me give you a hint. If A is equal to B and B is equal to C, therefore A is equal to C. So let me go ahead and look at my Unit 3 pink sheets. There you go. Transitive property. If A is equal to B and B is equal to C, then by the transitive property, A is equal to C. So if I look, if angle 2 is congruent to angle 6 and angle 6 is congruent to angle 7, then by the transitive property, we can say that angle 2 is congruent to angle 7. So basically, I just proved that angle 2 is congruent to angle 7. Remember, that's what I'm trying to prove here. So I'm going to jump right into the 2-column proof with the help of my notes here. Here are my statements. Here are the reasons. Statement number 1 says L is parallel to M. Well, L parallel to M, that's a given. The first reason for any proof will always be given. Statement 2 says angle 2 is congruent to angle 6. If we look at the picture here, angle 2 and angle 6 are congruent by corresponding angles. So I'm going to write corresponding angles for my second reason. Number 3, angle 6 is congruent to angle 7. Here's angle 6. Here's angle 7. We said that these two angles are congruent to each other by vertical angles. And then lastly, angle 2 is congruent to angle 7. If angle 2 is congruent to angle 6 and angle 6 is congruent to angle 7, then by the transitive property, we say that angle 2 is congruent to angle 7. And that's how you do the proof for the first problem of today's notes. Number 2, it says given that M is parallel to N, prove angle 3 and angle 8 are supplementary. So looking at the given, M is parallel to N, we can assume this is true. So I'm going to mark my picture. I'm going to draw a single arrow on line M and a single arrow on line N to tell the reader that these two lines are parallel. So we have parallel lines cut by a transversal and the angles are formed. Our goal is to prove that angle 3 and angle 8 are supplementary. I'm going to circle those two angles just to remind myself that I am trying to prove that those two angles are indeed supplementary. So here's angle 3, and here's angle 8. And the key word here is supplementary. The key word here is supplementary. So whenever I see the word supplementary, I think of 3 properties, and I'm going to need my pink sheets for this. One of the properties is the definition of supplementary angles. If two angles sum up to 180 degrees, then they are supplementary angles. Or the converse would be if they are supplementary angles, then the two angles sum up to 180 degrees. It's a biconditional because this is a definition. The other theorem or property that deals with the word supplementary is the linear pair theorem, which states if two angles form a linear pair, then they are supplementary angles. And then lastly, if we look at the pink sheet, the front side of the Unit 4 pink sheet, same side interior angles theorem. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. Supplementary means you add two angles together and set that equal to 180 degrees. So I'm going to make some notes here under the word supplementary. This could involve definition of supplementary angles. This could involve the linear pair theorem. And this could involve the same side interior angles theorem. So if I'm looking at the figure now, I can see that 3 and 6 are on the same side of the transversal, and they are inside of the parallel lines. So we say that these two angles are same side interior angles. So I'm going to make that note. Angle 3 and angle 6 are supplementary by same side interior angles. So angle 3 and angle 6 are supplementary by same side interior angles. Now, again, here's angle 3 and here's angle 6. If I look at angle 6, notice that it's congruent to angle 8 by vertical angles. Remember, we have two lines that intersect each other, and the angles across from each other are congruent. So angle 6 and angle 8 are congruent. So I'm going to draw a single arc here and a single arc there. And I'm going to note that angle 6 is congruent to angle 8 by vertical angles. So basically, if angle 3 and angle 6 are same side interior angles, and we know that angle 6 is congruent to angle 8, then we potentially have an idea on how this proof will go. We're saying that angle 3 and angle 8 are supplementary. Now let's jump right into the two-column proof. Here are our statements and here are our reasons. So number 1, M is parallel to N. The reason for that is always given. The first reason is always given. Number 2, angle 3 and angle 6 are supplementary. We said that these two angles are supplementary by the same side interior angles theorem. So keep in mind that angle 3 and angle 6 are supplementary by the same side interior angles theorem, because when I jump right into reason number 3, definition of supplementary angles, I need to provide a statement here. So what I'm going to do is I'm going to go back to the pink sheets, specifically finding the definition of supplementary angles, and it's read, if two angles sum up to 180 degrees, then they are supplementary angles. The converse of that, because it's a definition, if they are supplementary angles, then the two angles sum up to 180 degrees. So let's go back to the notes. Remember, angle 3 and angle 6 are supplementary. This is telling the reader that these two angles are supplementary in word form. So basically, what we should do, or how we should approach this, is we should use the other direction of this definition. If they are supplementary angles, then the two angles sum up to 180 degrees. So if we look at the examples here, we have angle C and angle D, they are supplementary. Angle C and angle D are supplementary. So if angle C and angle D are supplementary, then by the definition of supplementary angles, the measure of angle C plus the measure of angle D is equal to 180 degrees. And that's how we should approach this. Angle 3 and angle 6 are supplementary, then by the definition of supplementary angles, I will write the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees. So I'm going from word form to algebra form. Okay, so statement number 4 says angle 6 is congruent to angle 8. If we look at the diagram and our note here, angle 6 is congruent to angle 8 by vertical angles. So angle 6 is congruent to angle 8. And we're comparing two shapes using the congruent symbol. This is in the language of what? Well, since we have a congruent symbol, this is in the language of geometry. So if angle 6 is congruent to angle 8, then by the definition of congruence, what do I put here? So I'm going to go back to my pink sheets and read what the definition of congruence states. So we have the language of geometry dealing with shapes and the language of algebra dealing with numbers and measures. If segment DE is congruent to segment FG, then the measure of DE is equal to the measure of FG. If angle R is congruent to angle S, then the measure of angle R is equal to the measure of angle S. So we initially have a congruent symbol. So by the definition of congruence, I should change the congruent symbol to an equal sign, just like what the definition of congruence states here. It's going from angle R congruent to angle S to the measure of angle R equal to the measure of angle S. So I'm going to write the measure of angle 6 is equal to the measure of angle 8. And this is in the language of algebra. So one more time. If angle 6 is congruent to angle 8, then by the definition of congruence, the measure of angle 6 is equal to the measure of angle 8. Now before we jump right into statement number 6, we need to keep statement number 3 and statement number 5 in mind. Statement number 3 says that the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees. And number 5 says measure angle 6 is equal to the measure of angle 8. So let's read what statement number 6 says. The measure of angle 3 plus the measure of angle 8 is equal to 180 degrees. So what happened here was initially the measure of angle 3 plus the measure of angle 6 was equal to 180. The measure of angle 6 got replaced with the measure of angle 8 because statement number 5 says measure angle 6 is equal to the measure of angle 8. So I'm basically just replacing measure of angle 6 with the measure of angle 8. And replacing means substitution. So the reason is substitution property. So therefore, the measure of angle 3 plus the measure of angle 8 is equal to 180 degrees. Now jumping right into number 7, our last part for statement and reason. Well, the last statement should always be what we're trying to prove. So we're trying to prove that angle 3 and angle 8 are supplementary. That's what I should write here. Angle 3 and angle 8 are supplementary. So if the measure of angle 3 plus the measure of angle 8 is equal to 180 degrees, then what reason will lead me to this statement here? Well, if we remember, this is in word form. If angle 3 and angle 6 are supplementary, then by the definition of supplementary angles, the measure of angle 3 plus measure of angle 6 is equal to 180. That was in algebra form. So remember, if we look, the definition of supplementary angles, it's a definition that goes both ways. So you can go from word form to algebra form or algebra form to word form. And currently this is an algebra form. So if I say the measure of angle 3 plus the measure of angle 8 is equal to 180 degrees, then by the definition of supplementary angles, angle 3 and angle 8 are supplementary. The measure of angle 3 plus the measure of angle 8 is equal to 180 is an algebra form. Then by the definition of supplementary angles, angle 3 and angle 8 are supplementary, which is in word form. And this is what I'm trying to prove. Okay, so number 3, this one is different from the proofs that we just did on today's notes. It says, given that angle 1 is congruent to angle 2, prove that L is parallel to M. So if I look at this diagram right here, we cannot assume that these two lines are parallel. Why? Because that's what we're trying to prove. Now before, number 1, it had a given where two lines are parallel, and number 2, it had a given where two lines are parallel. Number 3 is different because, again, we're trying to prove that these two lines are parallel. So if you see something like this, or in other words, you're being asked to prove two lines are parallel, then the last reason should be one of your converse theorems. And if you don't know what I'm talking about, you should look back at your pink sheet containing all the converse theorems that we discussed. Remember that converse theorems prove lines parallel. We have the corresponding angles converse, we have the alternate interior angles converse, same side interior angles converse, alternate exterior angles converse, and the perpendicular transversal converse. So I'm going to make a note here. Prove that L is parallel to M. The last reason should be a converse theorem. And I know that's a lot of words, but it's a good note to have just to keep in mind. Now let's go ahead and start from the beginning. It says angle 1 is congruent to angle 2. We can assume the given is true. So I'm going to mark my picture. Angle 1 is congruent to angle 2. So I'm going to make that note. Angle 1 is congruent to angle 2. And that's because of given. And I'm looking at angle 1 and angle 2, I notice that these two angles are alternate exterior angles. So angle 1 and angle 2 are alternate exterior angles. What else do I notice? If I look closely, I can see that angle 2 has to be congruent to angle 3 by vertical angles. So I draw a single arc there because all of these angles should have the same measure. So I'm going to make that note. Angle 2 is congruent to angle 3 by vertical angles. So if I look at my notes here, angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So the implication here is that angle 1 is congruent to angle 3. So angle 1 is congruent to angle 3. Here's angle 1, and here's angle 3. What type of angles are angle 1 and angle 3? They are corresponding angles. If we look, if you're standing over here, it's kind of like saying you're standing over here. So they are corresponding angles. So my note would be angle 1 and angle 3 are corresponding. So what are we trying to prove? We're trying to prove that L is parallel to M. The last reason should be a converse theorem. So here's line L, here's line M. Are these two lines parallel? Well, we have two lines cut by a transversal, and the corresponding angles are congruent. So that means these two lines must be parallel because of the corresponding angles converse, which states if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. Okay, so I want to go ahead and fill out the proof for number 3. Here are my statements, here are my reasons. Angle 1 is congruent to angle 2. That's because of given. It says right here. B says angle 2 is congruent to angle 3. Well, we said that angle 2 is congruent to angle 3 by vertical angles. So here's angle 2, here's angle 3. These two lines intersect and the angles across from each other are congruent. So my reason for B should be vertical angles. So remember, we have angle 1 is congruent to angle 2 by given, and angle 2 is congruent to angle 3 by vertical angles. So if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then it implies that angle 1 must be congruent to angle 3 by the transitive property, which I wrote here but didn't specify. So the last statement should be what we're trying to prove. What are we trying to prove? We're trying to prove that L is parallel to M. So I'm going to write line L is parallel to line M. Why are these two lines parallel? Well, we have two lines cut by a transversal, and the corresponding angles are congruent. So by the corresponding angles converse, the lines are parallel. So my reason for that is corresponding angles converse. You need to write converse because remember, the converse theorems prove lines parallel. And I made a note right there, and you should too, as a reference. Number 4, it says, given that angle 1 and angle 6 are supplementary, prove line K is parallel to line I. So, I'm looking at the given. We can assume that angle 1 and angle 6 are supplementary. Whenever I see the word supplementary, I think of those three properties. Definition of supplementary angles, linear pair theorem, and same side interior angles. So any of these properties could be part of our proof. And now I'm looking at what we're trying to prove. It says we're proving that K is parallel to I. Whenever we're trying to prove something is parallel to something, it means our last reason should be one of the converse theorems. So converse theorem. Now look at the diagram. We know that angle 1 and angle 6 are supplementary. So I'm going to circle those two angles. Now from the word supplementary, I wrote three properties down. Definition of supplementary angles, linear pair theorem, and same side interior angles. What I want to do is try one of these properties. I'm going to try the linear pair theorem. Here's angle 1 and here's angle 4. If I look at these two angles, they actually form a linear pair. So I'm going to write that down. Angle 1 and angle 4 are supplementary by the linear pair theorem. And now I look at angle 4 and angle 6. These two angles are inside of the two lines, and they are on opposite sides of the transversal. So we can say that angle 4 and angle 6 are alternate interior angles. We cannot say that angle 4 and angle 6 are congruent. They could be congruent if the lines were parallel from the start, But we only know that these two angles are just alternate interior angles. But if there is some way to show that these two angles are congruent, then we can say by the alternate interior angles converse, lines K and I are parallel. So that's where the definition of supplementary angles will come into play when I get right into the proof. Now let's take a look at the proof. By the given statement, angle 1 and angle 6 are supplementary. So the first reason should always be given. Statement number 2 says angle 1 and angle 4 are supplementary. Here's angle 1, here's angle 4. They form a linear pair. So these two angles are supplementary by the linear pair theorem. So, if angle 1 and angle 6 are supplementary, then by the definition of supplementary angles, measure of angle 1 plus the measure of angle 6 equals 180 degrees. So I'm converting this statement, which is in word form, to algebra form. So this is word form, and now it becomes algebra form. For number 2, it says angle 1 and angle 4 are supplementary. Again, that's in word form, and I want to convert statement 2 to algebra form. So angle 1 and angle 4 are supplementary by the definition of supplementary angles. The measure of angle 1 plus the measure of angle 4 equals 180 degrees. This is in algebra form. Now for the fifth reason, it says symmetric property. What I want to do is review what the symmetric property is, and that's going to be part of your Unit 3 pink sheets, and it should be under algebra. Here you go. The symmetric property. If A is equal to B, then by the symmetric property, B is equal to A. So the order just switches. Statement number 4 says, if the measure of angle 1 plus the measure of angle 4 is equal to 180, then by the symmetric property, I should have 180 equals measure angle 1 plus measure angle 4. So then, if we look at statement number 3 and statement number 5, if the measure angle 1 plus the measure angle 6 is equal to 180, and 180 is equal to the measure angle 1 plus the measure angle 4, then by the transitive property, the measure of angle 1 plus the measure of angle 6 is equal to the measure of angle 1 plus the measure of angle 4. So this is where the transitive property comes into play. If 2 plus 3 equals 5 and 5 equals 1 plus 4, then 2 plus 3 equals 1 plus 4. Now look at number 6. If we look at both sides of the equation here, they both carry the measure of angle 1. So what I need to do here is get measure of angle 6 equal to the measure of angle 4. And I gotta use the subtraction property of equality. I gotta subtract both sides by the measure of angle 1. So this will go away, and that'll go away, and therefore I get the measure of angle 6 is equal to the measure of angle 4. So the seventh reason should be subtraction property of equality. So if we have the original statement here, the measure of angle 1 plus the measure of angle 6 is equal to the measure of angle 1 plus the measure of angle 4, then by the subtraction property of equality, the measure of angle 6 is equal to the measure of angle 4. Now, if we look at number 7, this is currently in the language of algebra because of that equal sign. So if the measure of angle 6 is equal to the measure of angle 4, then by the definition of congruence, I need to convert the language of algebra to the language of geometry. So I will write angle 6 is congruent to angle 4. And look at that. Where's angle 6 and angle 4 located? It's right here and right there. So I can go ahead and mark my picture. I can draw one arc here and one arc there to indicate congruency. And we said that angle 4 and angle 6 are alternate interior angles. And we just showed that these two angles are congruent. So the alternate interior angles are congruent. So, if we have two lines cut by a transversal and the alternate interior angles are congruent, so which converse theorem will prove that K is parallel to I? And we're going to be looking at our converse pink sheet. If two lines are cut by a transversal and the alternate interior angles are congruent, then by the alternate interior angles converse, the lines are parallel. So I'm going to write alternate interior angles converse. And there you go, that's number 4. The last problem for today, number 5, it says, given segment BE bisects angle DBA and angle 1 is congruent to angle 3, prove that segment CD is parallel to segment BE. Now look at the given. Anything from the given we can assume true. And that includes the diagram itself, which is a triangle. It is composed of segments. Remember, a segment is part of a line with endpoints. It doesn't hurt to turn these segments into lines, and I'm going to do so by extending them with dashed lines and drawing arrows on both ends. So we have two lines cut by a transversal. Now remember, from the given, segment BE bisects angle DBA. This is segment BE, and this is angle DBA. Now what happens when an object bisects another object? Well, remember, the word bisect means it splits an object into two congruent parts. In this case, this object is going to split this object into two congruent parts. Since this is an angle, the angle is going to get bisected, and we're going to have two congruent angles. So we can say that angle 3 and angle 2 are congruent to each other. And I'm going to make that note. Angle 3 is congruent to angle 2 by, well, what's the object in mind? Well, this is an angle, and it's being bisected by this object, or this segment. We call this segment the angle bisector. But we cannot forget about this part of the given. Angle 1 is congruent to angle 3. Here's angle 1, here's angle 3. We know that angle 3 is congruent to angle 2, and if angle 3 is congruent to angle 1 should have a single arc, because angle 1 and angle 3 have the same measure. So I'm going to write angle 1 is congruent to angle 3 by given. Now we have angle 1 is congruent to angle 3 by the given, and angle 3 is congruent to angle 2 by the angle bisector. What does this imply? Well, by the transitive property, angle 1 is congruent to angle 2 by the transitive property. So let's look at the diagram. Here's angle 1, here's angle 2, and we have these two lines cut by a transversal. Angle 1 and angle 2 are inside of the two lines here. They are interior angles. Not to mention that these two angles are alternate. They are on opposite sides of the transversal. So I can say that angle 1 and angle 2 are alternate interior angles. And I'm going to circle this part because these two alternate interior angles are congruent. Now I want to go ahead and approach the proof here. By the given statement, segment BE bisects angle DBA and angle 1 is congruent to angle 3. So the first reason should be given. Now if segment BE bisects angle DBA, then by the definition of angle bisector, angle 3 is congruent to angle 2. And then I get to statement number 3. If angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then by the transitive property, angle 1 is congruent to angle 2. And then the last statement is always what you're trying to prove. So, we know that angle 1 is congruent to angle 2. Here's angle 1, here's angle 2. They are interior angles and alternate. So therefore angle 1 and angle 2 are alternate interior angles and they are congruent. So I can say that by the alternate interior angles, what? Segment CD is parallel to segment BE. Now remember, if you're trying to prove lines parallel or segments parallel, you have to use one of the converse theorems. So in this case, our last reason should be the alternate interior angles converse. And now you are done with the proof. And I cannot stress this enough. The converse theorems prove lines parallel. Whenever you see something like this, if something is parallel to something under what you're trying to prove, you gotta use one of the converse theorems to show that these two lines or two segments are parallel.